Today we're going to remind ourselves what conditional probability is. So when we found the probability of dependent events, we had conditional probability. Our dependent events looked like this. So probability of A and B is probability of A times the probability of B, given that A has already happened. So this part right here in the back half of our equation is a conditional probability. It just means that something has occurred. We're taking something else into account when we find our probability. So we're going to do an example. We have these two spinners, and each spinner is spun one time. We want to find the probability that the first spinner lands on a 2, and the sum of the spinners together is 6. So I wrote that out, probability of 2 and a sum of 6. Well, probability of 2 is pretty easy. We can find that on our first spinner. It's just 1/4. But then the probability of a sum of 6, given that our first spinner was a 2, so we know this has to be a 2, that leaves us with only a 4 on the second spinner, which is another 4th. Multiplying them together is 1/16. Okay, we're going to use these same spinners, so remember what they look like. We're going to find the probability that our first spinner lands on an odd number, and then the second spinner gives us a sum greater than 4. So again, probability of an odd number, pretty simple. We get a half. Probability that our sum is greater than 4, given that our first spinner is odd. That gives us a few more options. So I went ahead and listed off all of our potential things. If our first spinner is odd, we have 1 or 3. In order for our sum to be greater than 4, if our first spinner landed on a 1, the second spinner would have to be a 4. If it landed on a 3, we could have 3 and 2, 3 and 3, or 3 and 4. So there are 4 total options that our second spinner could land on if our first spinner is an odd. So that's where this 4 comes from. And then we have to figure out how many total options are there for my spinners. So think about our first spinner. It has to be odd, which gives us 2 options. So we have 2 options for our first spinner, and then we have to test all 4 on our second spinner. So our second fraction is 4/8. The 4 comes from these 4 options. The 8 comes from the 2 odd on the first spinner and the 4 potential spots on the second spinner. Multiplying those together, 2 times 4 is where we get that 8. So now to find this overall probability, we have to take a half times a half, which gives us a 4th. Another common way to find conditional probabilities is given a table. So we have this table that talks about the seasons that people have their birthdays along with the years they were born. So we want to find what's the probability of a winter birthday given that it's 1993. So here we're obviously considering our month or our season. It's winter, but it has to be 1993, meaning I don't care at all about this 92 column or the 94 column. So I'm strictly looking at this 1993. This 1993 column becomes our total then, because it's given that it has to be in that year. So we add all of these up to get 45, and then winter, given that it's 93, our numerator comes from that box. So our probability of winter, given that it's 1993, is 16 out of 45. Okay, we can also reverse this. I want you guys to find what's the probability of my birthday being in 1992, given that it's spring or summer. So think about what's going to give you your numerator, what's going to give you your denominator.